Dear students, very good morning. Today we are going to see some important formulas in integration. Okay, some important formulas in integration. So especially we are going to see the integration by parts. Okay, so in that we often come across some of the formulas of integral log x dx. Second one is integral x log x. Third one is integral x square log x, and so on. Okay, we will use some of these formulas in our regular integration, but the biggest confusion between the students to apply the integration by parts is to apply at which moment is the biggest question mark, because the students are very familiar with Bernoulli's formula. Okay, so this is the generalization of integration by parts. So integration by parts simply telling integral u dv equal to uv minus integral v du, whereas Bernoulli's formula is telling integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. So where you have to keep the u as it is, you have to integrate this dv to find v. So after finding u, you have to differentiate this to find u dash, and after that you have to integrate this v to find v1. So here u and dv is there, you have to differentiate. Okay, you have to differentiate the u terms and integrate the dv terms to find u dash, and this is v, and this is u double dash, and this is v1, then u triple dash, then v2, like that it will go on. So the formula is uv u dash v1 u double dash v2 u triple dash v3, and you are having the signs alternatively. So the Bernoulli's formula is the alternative, it is actually the alternative, or it is the generalized formula for the integration by parts. Okay, but the biggest trouble in applying this formula is you are extending the differentiation until when the u power nth derivative is approaching 0 or it is becoming 0. Okay, so at least you have to get a constant. Okay, at least u power n should become a constant, so that the u power n plus 1, the next term will become 0. Okay, if u power n is becoming 0 is, then definitely you can say that u power n minus 1 is constant. Okay, so you have to stop when the differentiation or the any order derivative is becoming constant. Okay, you have to stop the derivative at that moment, so that you can stop the Bernoulli's formula at that moment. So when to apply the Bernoulli's formula means when you are having any x power of n, okay, any x power of n along with any trigonometric term, or with any exponential term, you can apply the Bernoulli's formula, because you are having one order, one hierarchy like ILA TE, that is I for inverse, L for logarithmic, A for algebraic, T for trigonometric, then E for exponential, right? So you have to give in this order the preference of choosing u. So only in this order only how to choose u. So this x power n comes under algebraic term. So after that you can have trigonometry and exponential, so that you can easily choose one of these as your what to say, dv. Okay, suppose if I am having x square sine 2x, means this is my u. Okay, this is my u and this is my dv. Suppose if I am having x square e power 3x, means this is my u and this is my dv. So what is clear here? Definitely it is not possible to choose this as u, and this is not possible to choose e power 3x as u, because here the derivatives of u should decrease, and at one fine moment it should become constant, and after that it should lead to 0. That is the concept of choosing u. Okay, here also in integration by parts also you are choosing the u in the same order. You are choosing the u in the same order. Okay, but here you are applying the integration one time. You are checking whether you have got the desired result or not. If it is not obtained, whether the integration is existing after you are applying the integration by parts one time, then you have to go for the integration once again. So when you have to stop this, when you are not having any integrating term in the right hand side, then you should not have any integrating term in the right hand side, you can stop at that moment. Okay, so in order to make you to clearly understand the concept of integration by parts, I am going to, and the what to say, and Bernoulli's formula, I am going to take this session. Okay, so here with some example I am going to show you. Okay, first one is we shall start with Bernoulli's formula, that is integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. Suppose if I am having integral x square then sine x dx, means what can I do? So here you have to choose your u and everything. Okay, so u equal to x square, dv equal to sine x dx, so that you can say v equal to, what is that, integration of dv is v, so integration of sin x is minus cos x. So the result for integral x square sin x dx is equal to uv means that is x square into minus cos x uv minus u dash is 2x u dash, v1 means integration of cos x is sin x. Since you are having that minus, here you will have minus uv minus u dash v1 plus u double dash. So you are going to differentiate this 2x once again, so that you will get 2. So here you are getting the integration of sin x is minus cos x. So since there is minus, you will get plus cos x. So the result for this is integration of x square sin x dx equal to minus x square cos x plus 2x sin x plus 2 cos x. Okay, So I have easily applied the concept of Bernoulli's formula. Okay, so after that what will happen, differentiating these two, this will become 0, this will become integration of cos x is sin x, 0 into sin x. So the terms after this everything will become 0. So it is not necessary to find after this, okay, since it is constant. So we have stopped here. So now you have got an idea when to apply this Bernoulli's formula, but when to apply the integration by parts, that is integral udv equal to uv minus integral vdu. Okay, so let me start with simple examples that is given already. Okay, that is I have given the previous page. Okay, see here we have taken 3 examples. Okay, we have taken we have taken 3 examples. So I shall show you that examples here. One is integration of log x dx, integration of x log x, integration of x square log x. Okay, so why I have chosen that integration of log x? Integration of log x dx, many students are getting confused with this formula, because we know that suppose if I am having integration of dx by x, that is equal to integration of 1 by x dx, means I will get log x. So the differentiation of d by dx of log x equal to 1 by x, and integration of 1 by x equal to integration of 1 by x equal to log x. So students are very familiar with this, but sometimes they are getting confused. Instead of asking integration of 1 by x, if in examination the students has to face integration of log x dx, means they are not familiar with the formula. So how to solve when you are not familiar with the formula? Here I am going to choose as u equal to log x, and dv is very simple, dv equal to dx. Okay, so here u dash and something I am not going to do that. Okay, and I tell you the reason behind that from the second example onwards. Here I am going to find v equal to integration of dv, that is equal to integral dx, so that v equal to x. So now tell the formula, integral log x dx equal to uv means log x into x minus vdu, integral v into, so v equal to x du, that is u dash, so du equal to, so when log x is given, its derivative will be 1 by x, so 1 by x into dx, so vdu equal to x into 1 by x into dx. Okay, so here I am having x log x minus both these two. Okay, both these x will get cancelled. You are having only integration of dx, okay, since one integration symbol is appearing, it is not possible to stop here. I have to go for another iteration, that is x log x minus integration of dx is x. Finally you can take the x as common, x into log x minus 1 plus c, or you can put plus c here, x log x minus x plus c. This is what integration of log x dx. I always prefer to say integration of log x dx equal to x log x minus x plus c, because when I used to say x log x minus 1 means sometimes there may be a chance to forget that this x is also multiplying this one, because sometimes you easier to pronounce like x log x minus 1 plus c. So the meaning is entirely different. Okay, so it is always better to say the formula with expansion. Okay, so x log x minus x plus c. Okay, now we shall go to the second formula. Okay, x log x, integration of x log x. Second formula, integration of x log x. So finally we are going to find the value of some big formula where the integration by parts is playing an effective role, effective way. Okay, so integral x log x dx. So here what is u equal to x, dv equal to log x dx. So the problem here is in the order of I can choose u equal to x and dv equal log x, means the problem here is when in the case of ILAT, in the case of the hierarchy of choosing the u, the logarithmic term is appearing first and the algebraic term is appearing next. But what my intuition is telling, when I choose u equal to x means then definitely u dash will become 1, u double dash will become 0, so that it will be easy. My intuition automatically tells like that. Okay, but we should not choose the u and v like this. If you choose like that means it is entirely wrong. Okay, it is entirely wrong. Okay, so what to do is what we are going to discuss. Okay, so now what comes first? U is coming first. U is coming first. So logarithm term is coming first. So u equal to log x. U equal to log x. Then dv equal to x dx. Okay, you have to choose like this only. Then du equal to 1 by x, v equal to integration of x dx, that is equal to x square by 2. So by integration by parts you will see x log x dx equal to uv minus, uv means log x into x square by 2, x square by 2 uv minus integral uv minus integral v du, that is x square by 2 into v du is 1 by x. So you have to add dx without forgetting, so dx. Okay, so this is equal to x square by 2 into log x minus, here this x square and x will get cancelled, so you are getting 1 by 2 into integral x dx. Since you are getting the integral symbol here, you have to repeat the same process once again. You have to repeat integration x square by 2 log x minus 1 by 2 into integral. Integral is now removed. Okay, so you will have x square by 2. So the formula is, what is the formula? Integral x log x dx equal to x square by 2 into log x minus x square by 4 plus c. This is the integration formula. Okay. Now we shall do third sum, because these formulas are very important. Third one is x square log x dx. Here u equal to, so what is the problem? It is not possible to apply by Bernoulli's formula here, because you have, when you apply Bernoulli's formula means that u should become 0 on continuous differentiation on each iterations. Okay, so you, after that u dash, after that u double dash, after that u triple dash, at one fine moment that u should become 0, but here the u will not become 0, so it is not possible to apply the Bernoulli's formula. It is not advisable to apply Bernoulli's formula, so go for integration by parts. Okay. Third one is integration of x square log x. So u equal to x square dv equal to log, see, we have made a mistake. Okay, if I choose like this means this is wrong. So what is u equal to log x, dv equal to x square dx. Very conscious. Okay, please be very conscious. Du equal to 1 by x dx. V equal to, this is integration, right? X cube by 3. V equal to x cube by 3. So the formula is integration of x square log x dx equal to uv, means that is x cube by 3 into log x uv. So okay, u equal to log x, v equal to x cube by 3 uv minus integral v into du. V into du means integration of x cube by 3 into du is 1 by x into dx. Okay, so here this 3 and this x will get cancelled, so you will get 2 here, that is equal to x cube by 3 into log x minus, you are getting integration of, so I shall take that 1 by 3 outside, 1 by 3 into integration of x square, okay, x square dx. So since you are having the integral symbol here, you have to go for one more iteration in integration, so that you are getting x cube by 3 log x, okay, x cube by 3 log x, then minus 1 by integration of x square is x cube by 3, so x cube by 9. So this is what the value, x square of log x dx, x square of log x dx. Okay, so this is the formula. So dear students, don't forget to put c here. Okay, don't forget to put c here. This is the formula for integration of x square log x dx. Now we are going to derive one important formula. So here it is the important for identifying when to stop integration by parts. Okay, sort of integration is, it is a formula e power ax cos bx dx. Okay, So this is what we are going to find now. Okay, this is what we are going to find now. So in this it is not possible to apply the Bernoulli's formula, because here according to ILATE trigonometric function should be chosen as u. So this should be chosen as u. So when I choose this as u, means after u dash, u double dash, u triple dash, etc. can be found, but none of this will become 0. Okay, none of this will become 0. So it is not possible to apply the Bernoulli's formula. It is not possible to apply the Bernoulli's formula. So we are going to solve it by using integration by parts. Okay, what is the form of integration by parts? The formula for integration by parts is integral u dv equal to uv minus integral v du. Okay, see, since in the previous examples you can see, at least after one iteration, the integration symbol is vanishing. Okay, the integration symbol is vanishing. Here see, first iteration you are having integration symbol. In the second iteration, that is becoming integrated, so the integration symbol is vanishing, so that will become your solution. But in this case, what is dv? dv equal to e power ax dx, right? So I shall tell you clearly here. Okay, u equal to, in this, u equal to cos bx, then dv equal to e power ax dx. Okay, so here du equal to minus b sin bx, v equal to integration of this, that is e power ax by a. Okay, so now by Bernoulli's formula you can integrate this. So here v is not it is v1, v2, v3, etc. So all the time v will be there, du will be there, that is du, d square u, d cube u, all time it is there. So it is not possible to apply Bernoulli's formula, and you will not get now an idea of when to stop the integration, that is when to stop this integration v du. That is what I am going to tell now. So I am going to take that given integration as I. Okay, let I equal to integral e power ax cos bx dx, that is equal to uv minus, uv means what, cos bx into e power ax by a, uv minus integral v into du. v into du means e power ax by a into du means minus b into sin bx dx. Okay, b sin x into dx, don't forget to put dx. Now you are having this, so e power ax by a into cos bx plus b by a into integral sin bx into e power ax dx. Okay, now the integration is not over since you are having the integral symbol. So in this also you have to choose what is u, what is du, and what is v, what is dv. Okay, so u equal to sin bx, du equal to b cos, du equal to b cos, u equal to sin bx, du equal to b cos bx, then dv equal to e power ax dx, v equal to e power ax by a. Okay, e power x by a. Okay, now here you are having e power ax by a into cos bx, e power x by a into cos bx plus b by a into uv. uv means sin bx into e power ax by a uv minus integral vdu e power ax by a into du is b cos bx into dx. Okay, don't forget to put dx. Okay, so now you don't know when to stop this. Okay, you don't know when to stop this. The values are e power ax by a into cos bx plus this is b square by b by a square, b by a square into e power ax sin bx minus b by a into integral e power ax cos bx dx. Okay, so what is this e power x cos bx dx? Have you seen it before? Yes, we have seen it before. It is nothing but I. Okay, it is nothing but I, so you can substitute this as I, but you are actually finding the value of phi. You are actually finding the value of phi. In the value of phi you are having I, so at this place you can stop the process of continuous integration. So you are getting I equal to e power ax cos bx by I can take integration, so what will happen? It will become a e power ax a cos bx by a square plus e power ax b is there, b sin bx by a square, then minus, you can take here also LCM, or please wait, we shall check it, minus b by a into I, minus b by a into I. Okay, now we shall take this to the left hand side, I plus bi by a equal to e power of ax a cos bx. Okay, plus e power of x is common, e power of x is common, e power of x is common. Here you have to check whether any b square is coming or not. Okay, yes, it is, b is multiplying here, b by a square, it is b means this is actually you are having on b and b by, it is b square by a square, actually it is b square by a square. Okay, so very carefully how to do this, it is b square by a square, b square by a square. So e power x is common, since e power x is common, you have to write and a square is also common, e power x by a square is common, so a cos bx plus b sin bx. Okay, Have you understand this, how this is becoming b by a square e power x and bx minus b into b is b square by a into a is a square integral e power x cos bx. Okay, so that is why you are having b square by a square into I. So now in this you can take I as common. If I take I as common means it is 1 plus b square by a square, that is equal to e power ax by a square into a cos bx plus b sin bx. Okay, so now you have to take the LCM here. The LCM is a square, so I into a square plus b square divided by a square equal to e power ax by a square into a cos bx plus b sin bx. Okay, now we want I equal to, so both these a square will get cancelled. Okay, both these a square get cancelled. You will get I equal to e power ax divided by a square plus b square, a square plus b square into a cos bx plus b sin bx. Okay, so what is this I actually? What is this I actually? I equal to e power integration of e power ax cos bx. I equal to integral of e power of ax cos bx. Okay, so that is I. So substitute it there. Therefore integration of e power ax cos bx dx equal to, you will have some integrating constant e power of c. Now you are having the value e power of x divided by a square plus b square into a cos bx plus b sin bx plus c. So here you have identified when to stop the integration by parts. Okay, when to stop the integration by parts. When to stop the integration by parts? Okay, when to stop one? When on continuous iteration of integration, when you are not getting the integration symbol, you can stop. Otherwise you have to wait until the same left hand side is repeating on the right hand side, or some product of or some value of the left hand side is coming on the right hand side. Okay, here it is coming right, minus I is there, here minus b square by square of I is there, so that we can stop the integration on this place. Okay, so this is very important. These four problems will make you to understand the difference between Bernoulli's formula and the integration by parts. Okay, also we have also seen a problem on Bernoulli's formula also. In the initial starting time we have seen the Bernoulli's formula. Okay, we have seen the Bernoulli's formula. So all these are very important. This will make you to understand the difference between Bernoulli's formula and the integration by parts. I hope you have understood what I had taught to you. So in the next video we shall see an interesting topic. So this is Dr. D. Prasanta Bharati, mathematician, signing out. Thank you so much.